all others in English class today.
Our fun is very triggered today, actually.
By Lance.
Okay.
No, by everybody.
So today we're going to talk about something that I call it the lone candidate test. I don't know that anyone else actually calls it that. It's not covered in your book, but it shows up on the AP exam sometimes. So
We're being really worried.
Our book is
quite a lot, actually.
Why?
Because I've been alive a long time and I paid attention. She thinks she's asking one question, but I'm asking answering a different question.
Okay.
You said, what do you know? And I said, quite a lot, actually.
Oh, funny.
All right, so the lone candidate test, we actually talked about this the other day in class.
Yeah, I remember that.
If f is continuous on an interval from a to b, open or closed, and x equals c is the only critical point on the interval, then f has an absolute maximum of f of c if f has a local maximum at x equals c, and f has an absolute minimum of f of c if f has a local minimum at x equals c.
Bars.
Bars? What?
Wooly, get it together, man. I'm literally trying.
How did you?
I'm sorry, he just
why you sleep.
Okay, so basically what we're saying is it's the only possibility for the maximum or the minimum. Okay, if you only have one critical point, there can only be one place where the graph turns around and goes the other direction, basically.
Yes.
And if that point is a local maximum, well, it's got to be the absolute maximum because the graph never turns again. Okay, and vice versa. So this is helpful at times, but only if you have a single critical point. If you don't, you cannot use this. If there's more than one critical point, it doesn't so much work. So we're just going to do a couple of quick examples. For each function, find the maximum and minimum value, if they exist, on the domain given, and justify your answers.
Calculator.
Yep. So, but before we can use the calculator, what do we have to do?
Find the derivative.
Yeah, find the derivative. Now, I suppose you could theoretically graph the derivative of this.
And just find where it's 0.
Yeah, but the problem is that it takes a really long time for it to graph. Have you guys done that where you tell it to graph the derivative?
Let's try.
Yeah, let's try it.
Wabbit emu?
We're gonna see how long
It's
this
the name of the emulator. The emu is for emulator. The wabbit is from Bugs Bunny. It is.
No.
Ooh, you wascally wabbit.
My mom's high
Elmer
school
Fudd used to say that all the time.
Who is Elmer Fudd? You don't know who Elmer Fudd is?
Oh my
Don't act like
goodness.
you know who Elmer
I
Fudd
do know
is. No, you don't.
know who
Yes,
Elmer
I know who
Fudd
Elmer
is.
Fudd. Mingwei, you know who Elmer Fudd is?
Nope.
See?
It's because he doesn't watch the videos. Oh my god.
Do you know who Bugs Bunny is? Yeah.
Do you know who
Yeah.
You know, the guy who hunts
Elmer
Bugs
Fudd.
Bunny is Elmer Fudd.
He's like, it's wabbit season.
the hunter?
Ooh, you wascally wabbit.
I feel like I'm in a fever dream right now.
It's
It's because you are.
All right.
maybe because you're like half awake.
Okay.
So if we actually told it to graph the derivative,
Where's my graph?
It's actually speedy.
Non-existent.
is it speedy?
No, not really.
It is.
There's a 0 at 0,
It's taking its
I
sweet
think.
time.
Ian's a liar.
and there's a 0 at
What has to be recited of x is equal to
Make your windows 0 to 5 x-axis.
Yeah, make sure your window is from 0 to 5.
0 and 4.5.
No, 0 and 5.
What? What?
It's loading.
Ah.
Uh-oh, what did I do? Oh, I didn't finish it.
For the minimum positive.
I mean, one.
Made it bad.
What is that from?
Oh, the water fountain?
Oh, mine's in degree mode. Dang it.
Oh, really?
Oh, me too. Mode. Oh no, it's not. Mine's in ready. Haha. Nerd. Yours like just doesn't do it.
Yours is really slow.
Well, how long is it gonna take? We should have put a timer on it.
Where is it?
Yeah.
I don't know. Maybe it's in the wrong
It's
mode.
very. It's
No?
like less than one. It's very narrow.
Yeah.
So maybe
Oh,
that's
it's
why.
very narrow?
Yes, you might not be able to see it.
So on my
Dude,
window,
-1 to 1 at the max.
Why do they people take advantage of the fact that they can switch them?
oh, yep, there it is.
The skinny boy.
Honestly, would this be faster than trying to find murder?
I don't know what's race. Ready, set, go.
Okay, I found it.
Did you?
What's the
What is
derivative?
it?
3x cosine of x minus 3 sine of x over 9x squared.
I think you already did that.
No, I didn't. I literally
While
just
we were
did it.
doing
No,
this
I
calculation.
actually just did that. You just didn't see it because I was
Mine doesn't show up.
They call me Flash, right?
Your window's wrong.
I saw the raw window.
Make your y minimum be -1 and your y maximum be +1. The problem is that it's so close to the axis you can't see it.
I know.
What is
I'm
wrong?
sorry. Why are you talking to the people? No, that's not funny. What do you mean it's not funny?
Shut up, Brett.
You got something to say about that?
I do actually. 9x squared.
So I don't know that it makes much difference on this, but just know, generally speaking, when you graph a derivative, it's kind of slow. Either way, we find that we go from a negative value of the derivative to a positive value somewhere between 4 and 5.
It's like exactly 4.5.
Is it exactly
No.
4.5?
No, it's
4.49 something.
4 and 3
So not exactly 4.5.
Well, very close to 4.5.
4.4 is my guess.
It's 4.49.
No, 4.4 is my guess.
It's 4.49.
No,
That is
I'm
my
guessing
guess.
4.4.
I'm guessing
Yeah, I didn't
4.49.
want
Oh, yeah.
It's really close to 4.5.
Right.
Let's play the truncation game.
Okay.
You need the digits, so 4.493.
That's not how truncating works.
It is though.
No,
How do you think truncating works?
4.
Just chop up all of
Yeah.
the digits.
We have to have 3 decimal place
Well, who
accuracy.
made that rule?
College Board,
Well-
Monopoly. I beat you.
Jesus,
It's just really slow.
And at this point, our graph of the derivative changes from negative to positive. So what do we know about f?
It's
Local min.
Yep. Has a local min
Shut up.
at x is equal to 4.493. Why are you making snake noises?
The zipper's name.
Because f prime changes
This is an odd shared experience.
from negative to positive at x equals 4.493. So far, we have only made a local argument, right? We have justified that it's a local minimum.
is absolutely.
So, therefore, since f has only one critical point, and is continuous, f of 4.493, which we need to put into our calculator, And what I'm going to do is, since that value is already stored in its brain at the moment, I'm just going to do sine of x divided by 3x. I don't know if I need parentheses around the 3x or not. I think that I may. So it's negative 0.072 is the minimum of f on the open interval from 0 to 5. So it doesn't have a maximum on that interval. Why doesn't that contradict the extreme value theorem?
Wait, why doesn't it have a maximum?
Pardon?
Why doesn't it have a maximum?
I just said that it doesn't.
Oh.
I didn't say why. But it doesn't. It does not have a maximum. It has a minimum, but no maximum. Why doesn't that contradict?
Is it because it's an open interval?
Yes. That's exactly right. If it had been a closed interval, one of those two endpoints would have been the absolute maximum, the location of the absolute maximum. Very good. All right, let's take a look at this next one. One very similar to this was on the AP exam several years ago. It was part of a free response question, and it was kind of fun to watch people absolutely lose their minds. Except we had to grade it then, and it was a mess. So I'll take the derivative first this time. And actually, you know what? I'm going to rewrite this as 20 times 1 plus x squared to the negative 1 power, because then it'll be faster to take the derivative. It'll be negative 20 times 1 plus x squared to the negative 2 times 2x. So the only place where that could be equal to 0 would be at x equals 0. Because this 1 plus x squared to the negative 2, that all goes in the denominator. So that's my only critical point. Okay? I'm going to go ahead and say that is the only critical point. So now I just need to figure out if that's a local minimum or a local maximum. So if I'm looking around 0, if I pick a value of x greater than 0, I've got a negative over a positive, so y prime less than 0. If I pick a negative number, I've got a positive over a positive, so I've got y prime positive. So since y prime changes, from positive to negative at x equals 0, y has a local maximum at x equals 0, and since y is continuous, and x equals 0 is the only critical point. Yeah, and I know I've said it already, but want to get it all in one sentence. y of 0, which is equal to 20, is the absolute maximum. And again, because it's an open interval, the extreme value theorem does not guarantee that we'll have minimums. Okay, any questions? Okie dokie. Then I went ahead and gave you the worksheet, so you should be good to go.